Welcome to the lecture on basics of welding process. Now, let us get into the process. Till now, we saw fusion welding process. What are all the elements in the welding? We all saw that. Now, let us get into a process called as shielded metal arc welding. So, SMAW. So, this is the short form which is used, also known as manual metal arc welding or stick welding. It is widely used for fabrication and maintenance. Typically, in construction industry, we use this welding process, which is called as manual metal arc welding process, right. So, here there is an electrode. This electrode melts, material is deposited. It involves generating an arc between the electrode and the workpiece, melts and it deposits. The temperatures reach as high as 5000 degrees Celsius. So, while melting, do you remember I talked about something in the past called as wetting. Wetting is very important because this wetting only allows the material to flow. So, when you melt the alloy material from the electrode and the base, they should be miscible. Miscible means they should be allowed to enter inside. If you take the unit cell, diffuse inside and they form an alloy. And rules for alloy, we have seen it in the basics of alloying in the lecture. We saw that. So, Humery rules have to be formed. So, that is very important, which is considered. So, the molten metal from the electrode combines with the base to form a weld pool, which cools and solidifies and forms an alloy. Immiscible materials, if you do, then what happens? There is always a crack. So, there has to be proper understanding of the base material and the electrode material what you use. A burning flux coating creates a protecting shielding. This is what I said, protecting shielding, and forms a slag around the weld. After the weld cools, the slag is chipped off by the hammer. So, we have seen this in the beginning, touch start. So, the arc initiation involves starting the arc between the two electrodes. Two methods are commonly used. Touch start, as I told you, you touch it, start. So, you touch it and then you pull it up. So, the electrode is briefly touched to the workpiece. Briefly is very briefly, a second, causing a short circuit. First moment you touch, there is a short circuit, and once there is a short circuit, there is a heat phenomena that raises the current and the temperature at the contact point. Why is that important? Because you wanted to initiate the melting. So, you touch it, short circuit, heating happens, melting happens, and now you pull it up. So, now you start doing it. This leads to local melting and vaporization of electrode and workpiece, generating a free electron that ionize the air, creates the plasma and which initiates the arc. So, friends, this is very important. There are two methods here. This is a touch start. This is very commonly used. The other one is high voltage discharge. A high frequency unit introduces high voltage into the weld circuit, creating a short electric field. High frequency unit, AC unit, right? AC unit, wherein which you will have variable frequency drives are there, and you can try to do it, or high frequency you can try to take it in kilohertz, create a high voltage into a weld circuit, creating a strong electric field. This high voltage pulse initiates the arc without contaminating the electrode. So, this will try to create the heat phenomena, so and then later the current can flow through easily. The other term is arc crater. This is a small depression formed in the parent metal due to arc penetration with molten metal piled around it. So, this is arc crater which is there, a small depression formed. So, in the parental metal. So, what you do is you have a small depression, something like this in the parent metal due to the arc formation. and which molten metal piles around it, something like this. So, the depth of the crater depends upon the metal thickness and used for the judgment of the arc penetration. Arc penetration is also one important parameter which we do. Arc length we have already seen. The distance between the electrode tip should be generally between 2 mm to 4 mm. That is the distance, 2 mm. You take your scale, 1 centimeter is this much. So, 2 mm, 4 mm is too small, right. It should be consistent for optimum results. And where is the big difference coming in welding when you do manual arc welding is here. Consistently maintaining 2 millimeter and 4 millimeter while doing one electrode itself is a challenge. That is why we go for automation. Arc stability. So, this shorter length will lead to arc stability. A stable arc, uniform and steady, produces a good weld bead and defect free welding. To maintain the stability, minimum arc variation length is essential. So, adding arc stability elements in flux can also help. As I told you, we have seen the example in the flux, one is to oxide and the other one is arc stability. You can do that, but predominantly it comes by arc length. So, when we talk about polarity, there are two types of polarities. When you use a DC welding, there is straight polarity and reverse polarity. In straight polarity, the electrode is negative, the electrode wire which you use is negative, the workpiece is positive. When in the reverse, it is reverse. Workpiece becomes negative and the electrode becomes positive. In AC, polarity changes periodically while within each cycle. In AC, it switches alternating current because here it swings positive, negative, it swings. This is alternating current, right. So, it swings periodically, it changes. Okay. You can do straight polarity, you can do reverse polarity. Straight polarity has an advantage of deeper penetration. Reverse polarity has an advantage of smearing and spreading without getting deeper. So, direct current straight polarity, which is called as DCSP, about 67% of the heat is generated at the workpiece, while rest of the heat is generated at the electrode. Because the heating major happens, because here there will be a pool which is to be formed, right. So, the electrode, it need not have very high temperature because the substrate are heavier, it will have more surface area. So, more surface area which will lead to more volume. So, you need lot of heat on the base. So, that is why we said 67% of the heat gets into the workpiece, right. 37 gets into the electrode. Hence, bare and medium coated electrodes are used. Deep penetration happens in direct current straight polarity, which I told you. Then mostly used for thicker welding joints we go for. The other way around is direct current reverse polarity. Here 67% of the heat is generated at the electrode, while 33% is given to the workpiece. So, when you give it to the workpiece, what happens is, so now instead your electrode is like this, the workpiece is like this. So, now more amount of melting will happen from here and this will try to create shallow welding or large surface area welding will happen, which need not give you a good strength, but will give you primarily joining only. So, hence heavily coated electrodes are used to prevent overheating and melting of electrodes. Shallow penetration, deep penetration, shallow penetration. So, on the surface you can try to do it. Mostly used for welding thin joints, we use reverse polarity, because in thin joints what happens, if you try to put a very high current, the workpiece itself will melt, Joule heating effect, I square RT, right, it will itself melt. So, in that case what we do is, we try to give maximum to the electrode. So, that is what is used here. So, DCSP, DCRP, very important. You should try to take a judgment whether to do deeper or shallow. Arc blow. In DC welding, arc blow refers to wandering of the arc due to magnetic field created by current flowing through the electrode workpiece and the ground clamp. What we are trying to say is, when there is a electric field very high current, there is flowing there. So, what happens is, there is, when the current flows, there is a lead to the magnetic field. So, this magnetic field which is created because of the current flow will sometimes try to disturb the arc which is getting there. So, moment it is disturbed, then the arc, whatever, see, its arc is a very small thing between the electrode. Now, there is a magnetic field which is there. This magnetic field will not allow the arc to be stabilized, it will disturb. So, that is what is called as wandering, like a blind man wandering in the space, right, something like that. Arc blow refers to wandering of the arc due to the magnetic field. This magnetic field you did not create, it happens because of the current. Current, magnetic field are linked. The magnetic field bends the arc form its intended path, especially at the beginning and the end of the weld, where the magnetic field concentration is very high. So, unlike in DC welding, AC welding does not experience arc flow because the polarity changes alternatively. So, it is a phenomena more common in DC supply. So, we have to be careful. So, arc blow can cause porosity and other defects, whatever it is, it can, because moment the heat swings, and heat swings is not so much, it will swing in a very, very small millimeter, so that you get it. So, now we have seen the submerged arc welding process and all the phenomena. So, we will try to now look at the advantage and disadvantage. It is simple, low cost, portable, that is why you use it at any place. It can be used in any position where you want to have very high weld quality. Variety of electrodes and different materials can be tried. What is the limitation? The electrode length is limitation because it depends on the electrode length. At the end, suppose you are halfway welding and the electrode ends. So, at that point of time, what will happen is, there will be a discontinuity in the flow of material and solidification. So, this part would have solidified, this part is yet to solidify because you are manually changing the electrode. So, because of that, there can be discontinuity in the material form, that leads to crack. Then requires cleaning when the new electrode is used, reducing weld speed. So, the other difficulty is, the controlling is little difficult as compared to that of the manual inert gas welding process, which we will see later. So, where all it is used: fabrication, maintenance, repair job, shipbuilding, construction industry. Gas pipeline, they use manual arc welding, sir. Then buildings, bridges, tanks, boilers, automotive, aircrafts, everywhere they use this process, so that it is easy. If you want to automate it, replace a man by a robot, then you can go with a wire feeding. Tungsten inert gas welding, TIG. It is also called as gas tungsten arc welding process. So, here also there is an arc which is created between the electrode and the workpiece, and here the tungsten, whatever is used as the electrode, it is not consumable. So, we have this is a base, this is the circuit what you hold. So, there is a shielding gas which is there. There is a tungsten electrode which is this one, which is not melting, non-consumable. So, this tungsten does not melt and get deposited. Second thing, tungsten is too heavy. So, when it gets mixed, it will create lot of defects in the welding. So, the electrodes often contain thorium oxide or zirconium oxide to improve the electron emission and arc stability and easy restart at low currents, the electrode. So, electrode is this. The filler material is added separately if it is needed. So, you can try to heat the base material and join, possible, or you can try to have a filler material which is there in the heated zone, it melts and deposits. The filler metal is added separately if needed. The process is conducted in an inert gas atmosphere, so that what happens, you do not get any defects on the weld joints. Argon, helium, nitrogen to prevent contamination of the molten metal pool, with argon being the most commonly used gas due to cost effectiveness and smooth arc action. Both AC and DC source can be used for TIG process. So, here if you look at it, this is how it is. So, you have an electrode which is used to create an arc, and then there is a filler rod which is there where it flows in the material. So, the tungsten inert gas welding, a non-consumable tungsten electrode is mounted in the holder. So, here it need not be heavy, it will be one rod and this rod is not consumed. So, you do not bother. So, every time what you do is you have to use both this one to hold the arc and this one to feed the filler, or you can automate the process. The welding process begins by striking an arc, again the same thing. To generate an arc you have to touch and then striking an arc between the workpiece and the tungsten electrode in the inert atmosphere. So, you can see here there is an inert gas also flowing. So, you can see weld gun and then there is a inert gas also flows along with it. Right. So, the arc can be initiated either by touching the electrode to a scrap metal piece or using a high frequency unit, which we saw. Once arc is initiated, then the process continues. The welding torch is inclined at an angle 70 to 80 degrees, normal 90, 70 to 80. Okay. Why? Because the filler has to come in an angle. So, the filler material, if needed, it is added by dripping the filler into the weld pool. So, as I told you, in submerged arc, here also you have DCSP and DCRP. So, this is the same, we do not have to worry about it. And then we will only see a new thing which is called as ACHF, which is alternating current high frequency. It is used for aluminum and magnesium, where high frequency are used in helping the oxides not to be formed or oxide cleaning action. So, if you look at in close microscopic view, you will see here the direction of travel which is happening this way, and you see a current conductor is coming, a shielded gas is coming through. So, this shielded gas protects, this is the inert atmosphere which protects. There is an electrode which comes, this tries to work with the, come in contact with the workpiece to create an arc. There is a filler material, this filler material can have a coating or it can come as bare. So, this is the microscopic view of the process. So, non-consumable tungsten electrode, you can see here gas shielding, the gas is fed around it and then you can see there is an arc, filler material. So, advantages, disadvantages are straightforward. It can be used for thin materials, both ferrous and non-ferrous can be done. It can provide very clear visibility of arc and in the workpiece. Stainless steel, mild steel to stainless steel can be welded, dissimilar material also can be done. Since it is exactly focused, the heat affected zone is less as compared to that of manual arc welding. So, TIG is slower than MIG, TIG is tungsten inert gas, MIG is metal inert gas and prone for contamination. The tungsten is the same thing, tungsten is used, that is replaced by metal. So, the tungsten contamination can cause brittle. Suppose in case tungsten melts, it is very heavy, so it will fall down and it will create brittle welding. So, it is costly. So, application you can see non-ferrous materials, majority of them we use TIG process, weld aluminum, magnesium, copper, nickel, titanium. See, all the aerospace and automobile uses magnesium and titanium, we use only TIG process, right. Zirconium and hard surface alloying we use. The welding of expansion bellows means these are something which tries to give you a cushioning effect. Bellows, transistor casing, TIG, instrument diaphragm, thin instrument diaphragm joining, TIG, then joints, seal joints, TIG, welded shield plates and thin sections, TIG. So, you should now understand non-ferrous, which is a thin, TIG is used. When it is a heavy structure, it is going to be arc welding process. So, a small difference between TIG and MIG, MIG is metal inert gas. So, the gas metal arc welding or MIG welding uses an arc to create a coalescence between a continuously fed metal electrode and the job. So, now you see the difference, continuously fed metal electrode. In TIG, tungsten electrode which comes, filler which comes, you try to melt. But in metal, the metal itself comes, the shield from the spool it comes. So, you have this nozzle where is then shielded gas. So, you can try to have and this can metal. The process is shielded by inert gas such as argon, helium, carbon dioxide and that does not require flux. Okay. So, this is very important. The process is shielded by inert gas which does not do it. So, here the metal melts and it drops down. So, in MIG a consumable metal wire is used. So, we can try to use either DCSP or DCRP. Generally, we use RP for stable arc and efficient metal deposition. The arc length gap is between 1.5 to 4 millimeter, and the torch remains at 10 to 12 from the workpiece with an arc length of this much. So, the arc length is maintained as constant such that you can get the best welding joints. So, there are self adjusting arc, there are self controlled arc. There are two types of arc which is possible in the metal inert gas welding process. So, the electrode feed adjusts automatically, which is called as self adjusted arc. So, if you look into it, friends, it is almost everything comes and falls as arc length, arc. So, if you see what is arc, arc is nothing but flow of current. So, if you can control the current flowing, or if you can control the voltage flowing, and if you can sense it properly, then accordingly you can help in feeding the electrode also. Suppose if the arc length is too short, then what happens? You have to feed faster. So, you can do it. So, in welding, it is interestingly that you can control the process very nicely. So, the electrode feed adjusts automatically. Decreased arc length increases current. Increased arc length decreases current. Now, you can see how beautifully it is doing. So, you closely watch the animation which is here, you will understand. Requires power source with flat characteristics. As I told you, constant voltage, constant current, you can also do it. Self controlled arc. The electrode feed rate adjusts with motor speed. Decrease arc length decreases the motor speed, so it is vice versa. It requires power source with drooping characteristics. So, we will try to see flat characteristics and drooping characteristics later. So, is that clear? So, you can have two of this. So, this tries to automate the metal inert gas welding process. Advantages: deep penetration and effective for both thin and thick. TIG is exhaustively used for thin, metal is used for both thin and thick. So, fast with higher deposition rate. It can be automatic, flux free, clean and spatter free metal. So, we prefer metal when we try to do many of the welding processes. So, it reduces distortion, requires less operating skill, because majority of them you can control it by these two processes. One is self adjusting arc, self controlled arc. Disadvantages are straightforward. Applications, you can see weld carbon, silicon, low alloy, stainless steel, heat resistance alloy, all these things are possible by MIG. So, if you ask compared to manual arc, MIG can be chosen, but still manual arc has its own advantage. So, MIG and TIG I am just comparing, so that you will try to appreciate. TIG uses a permanent non-consumable electrode. Here we use metal, which is a copper wire, stainless steel wire or mild steel raw wire can be used. Consumable metallic electrode are used in this process. Filler metal may or may not be used in TIG, because you heat it and join. So, you do not need a filler. Then here in metal there is a wire is used in the MIG welding process. The penetration is not as deeper as compared to that of MIG. Here both AC and DC can be used. In MIG only DC can be used. TIG thickness can be limited only to 6. So, here thick and thin can be done, it can go up to 40. The electrode feed not required in case of TIG, but here it is required. That is why you saw these two here, self adjusting arc, self controlled arc, these two are there, right. So, the electrode feed can be adjusted with the motor speed, with the arc speed. So, next is weld speed is slightly lower, here it is higher. The TIG welding torch is water cooled, here there is no cooling required. The additional fixtures required to hold the workpiece, here fixtures are required for holding, because heat will be there to distortion. TIG requires high skill, MIG requires not much of high skill. So, this clearly distinguishes when to go for MIG and when to go for TIG. But here the commonality is going to be the inert gas flowing around it. So, next let us try to look into plasma arc welding process. Plasma arc welding uses a constructed arc between a tungsten electrode and a nozzle or the workpiece. So, what they are trying to do is they are trying to tell between the tungsten electrode, this is tungsten and this is the nozzle. So, the circuit can be closed by creating these two and creating a plasma, or this is the workpiece. You can try to have a circuit closure between tungsten and the workpiece. Okay. It employs two inert gases, one for forming the arc plasma, the other thing is shielding it. Two separate entities are used in plasma, first to create, then to shield. The filler metal may or may not be added and the pressures are typically not used. It is almost like your TIG. If you want, you try to add a filler if necessary. So, here you can see here the arc is created and then the heat is gone. So, now in the heat zone you want to keep a filler, you can keep, otherwise you can melt the material and then join. Okay. Principle of operation, plasma arc welding is a constricted arc process. Right. The arc is constricted with the help of water cooled small diameter nozzle which sequences the arc, increases its pressure, temperature and heat intensive and thus improves arc stability, arc shape and heat transfer characteristics. Improves arc stability as compared to that of TIG, MIG and submerged arc welding. Arc stability is very high, arc shape is good and heat transfer is also highly efficient. So, in plasma there are two types of arc processes. One is non-transferable, the other one is transferable. If you see transferable, it is between the electrode and the workpiece there is a flame, a heat flame which is a plasma which is created. Arc forms between the electrode and the workpiece. It has very high density and the plasma jet velocity is also very high. It is used for high heat application. The same thing when you have non-transferable, it is between the electrode and the nozzle itself. So, the plasma is created between these itself, right, and this is the arc which is getting created. So, now the arc is formed between the electrode and the water cooled nozzle. Right. So, plasma exits as a flame independent of the workpiece. So, the workpiece can be conducting, workpiece can be non-conducting. So, used for ceramic and metal paints with low energy densities, you can use non-transferable arc. If you use a highly insulating material and if you want to join, how do you do it? So, you can do it by plasma. So, here again you can have a filler, you do not have a filler. So, transferable, higher end, high velocity it comes and hits. So, again we should know a little bit about the power supply. So, plasma arc welding PAW, okay, welding system consists of the following equipments. Power supply, a DC power supply is used with a drooping characteristics and open circuit voltage of 70 volts and above. So, we will see about the drooping characteristics in the next lecture. High frequency generators and current limiting resistor arc are used in the arc initiation. The plasma torques can be transferable and non-transferable. We try to use for creating plasma and we try to use shielding gas. So, two inert gas or a gas mixture is used. The orifice gas at a lower pressure and flow rate forms the arc plasma and the protection will be at a higher plasma. So, you play with the flow velocity and then you try to do it. So, again the advantages and disadvantages are clear. So, now we will only look at the applications here. So, it is used for welding high performance alloy, for example, cryogenic, aerospace and corrosion resistance welding process. Corrosion resistance material it can do. For cryogenic also material it is used, where we talk about -30, -40 it is used. So, it is used for stainless steel, the plasma torch for spraying, welding, cutting, it also can be used. So, moment you transform this, you try to use this alone, right, it can be used for cutting because you have a high heat, right. You can use for joining, and here in between this non-transferable, I fill a powder, so then this powder can be used for spraying. So plasma spraying is possible. That's what I have told you. So plasma torch for spraying is you feed a powder. Then welding, you keep a rod. Then if you don't put this and that, you just use it as a flame heat source, it can be used for cutting. So all are possible by the plasma welding process. Next, let us look into submerged arc welding process. This is used exhaustively in heavy engineering application. In submerged arc welding process, an arc is formed between the metal electrode and the workpiece submerged under flux. So you see here there is a flux pouring hopper. So this is a flux pouring hopper. They go first, they keep feeding and they go, and then you have an electrode which is there. So now the electrode is submerged into the flux and it does joining. So the continuous feed electrode melt acts as a filler rod. So you can see here this one, this portion is here, whatever gets created is the arc where it is created by continuous feeding of electrode. Right. So large electrodes up to 12 millimeter can be used, and currents like 4000 amps can be used. So the rate of deposition can go up to 20 kgs per hour. So the speed, it can go for 5 meters per minute, it can go to that speed. The thickness which can be welded can be up to 75 millimeter in one pass, right. So this is submerged arc welding process. Majority of the time we use a robo or we use a machine where it is continuously feeding, so it can be done. For example, you try to take two thick rings, you put the two thick rings which is used for sewage system or for the heat exchangers, very big heat exchangers. The diameter can be 6 meter, 5 meter, 3 meter. So you take these two rings and then we put the submerged arc welding process. It goes around and then it joins. So the principle is the submerged arc welding. The arc is stuck by touching, and then the electrode to the workpiece, and then the spool is fed, and then you start doing the process. So this gives more clarity. The flux is fed first, then there is a electrode which is continuously fed. So you can try to go through it. So once the weld is done, then you will have a slag. So after the weld is over, we try to use the chipping hammer, remove the unwanted slag which is there, and the weld zone forms, right. So this is the weld metal, the molten metal is formed here. This is the workpiece. So the flux melts, becomes conductive, and also allows current to flow. No pressure is applied. The solidified flux is used for joining. So advantages, this spatter and all will not be there. It will be a clean joint and you get a heavy thick metal welding happening. So these are some of the advantages and disadvantages. You can see application, bridge girders can be used, water pipelines, railway structures can be done. Nuclear industry, they also use submerged arc welding process. Okay, ideal for mass production in steel sections. So we have electro slag welding process. Electro slag welding process is very similar to submerged arc welding process, but performed in a vertical position. It involves casting filler metal between the workpiece in a single pass. Electro slag welding, ESW. The heat is generated in the same way, rest of the things are same. The electro slag welding starts with an arc, same. The temperatures go up to 1500 to 1900. Multiple electrode distributes heat for longer weldings. Water cooled is used and the flex shielding is also tried. So this is how the electro slag welding process is there. Electro slag welding process, what happens is you have to go from bottom to top. Very thick joint has to happen. So we continuously feed it. So there I said a ring will be rotated. Here it will go vertical top. Right? So, it is economical for thicker long plates with high deposition rates. Then low flux consumption is there and the well speed can go very high. Disadvantages are this, then the fabrication of the high pressure vessels, a frame of heavy mechanical and hydraulic is used and then you try to get it. So, the other one, this is electro slag welding. Now, we will see electro gas welding. So, electro gas welding is an arc welding process where the arc forms between continuously filler metal electrodes and weld pool in the vertical position. Again, rest of the process are the same. So, you have it like this, which is called as electro gas welding process. So, here you see that there will be water cooled, so that the heat whatever is getting generated is removed. This is the vertical is the direction which is moving, and then you have electrodes, right. One is face side electrode, root side electrode, two electrodes can be used and then you can try to join. So, this in which the shield gas is fed, right. So, it can go like this top and then you can fill it up. So, gas electrode welding. So, if you look into it, electro slag welding also can do the same, and it is almost the same if you look at it with a very small minor difference. So, advantages and disadvantages are clearly given. So, it can go up to 8 kilometers per hour. So, we saw in this lecture various fusion welding processes, metal arc welding, submerged metal arc welding, the tungsten inert gas welding, metal inert gas welding. We also saw welding can happen in horizontal vertical direction. We saw electro slag electro gas welding process. So, I am left with one question for you. Throughout my lecture, I said reverse polarity and forward polarity. I have also told you the difference. So, now you look at it, where can be the application for reverse polarity and forward polarity in real time. This will be one assignment. The second assignment is going to be why steel, mild steel is always used as AC welding, whereas non-ferrous material we always use DC. A second question that you should ponder. The third question is, what is the influence of magnetic field and electric field? Can I control electric field to use magnetic field which is getting generated, or can I use magnetic field which is generated to control the electric field? See what is the relationship and how can you do it. So, these are three things which you can always look into it, read, look at many of the references which are there, and then you try to educate yourself. Please have a look of this and then we will continue in the next lecture. I will also try to talk about the drooping curve and other characteristics in the next lecture. These are the references which we have used in preparing the lecture, and thank you very much.